Let's look at some more irrational number problems. So let's try to answer this question. Prove that square root of 3 is not rational. So let's try this question. Let's prove that square root of 3 is not rational. So what we're going to do is we assume that square root of 3 is rational. Alright, let me do this. Okay, so we assume that square root of 3 is rational. And if it is rational, meaning, so we say that is it can be expressed in the form a over b where a and b have no common factors b is not equal to 0 and are both so they're not equal to 0 and are both a and b are members of Z. So it is important that you write this so that the whoever will be marking or assessing your answer should know exactly what you're doing. So to prove that, we assume that square root of 3 is rational. That is, it can be expressed in the form a over b where a and b have no common factors and b is not equal to 0 and a and b are members of integers. So then we say if square root of 3 is equal to a over b, so then of course we square it, get rid of this square root, do that. Okay, and what we're going to have is 3 is equal to a over b, the both squared, and in this case we're going to have a squared is equal to, sorry, is equal to 3b, 3b squared. So in this constant, in this we can see that a as a is divisible by 3. You can see that a is divisible by 3, where a is divisible by 3. So since a squared is divisible by 3, is divisible by 3, so it's a, since a squared is divisible by 3, so and so is a is also divisible by 3. Now from here we say, okay, a so a is equal to 3r. So what we can do is simply we can substitute into this equation right here, and say, okay, 3r so squared also is equal to 3b squared. When you substitute, it's going to be 9r squared is equal to 3b squared. So it's over 3 over 3. These two cancel out. What we have is 3r squared is equal to b squared. So as you can see, b here, b squared is, so yes, since since b squared is equal to 3r, and b squared is divisible by 3, b is also divisible by 3. So as you can see, a squared is divisible by 3, b squared is divisible by 3, a is divisible by 3, b is divisible by 3. So since a and b have common factors, which is contrary to our assumption, hence it is irrational. So let me do this. Hence over 3 is irrational. So just show you what we said in our statement. So we said we assume that this is rational, that is, it can be expressed in the form a over b, and a and b have no common factors. So but here we found out that they have common factors, so meaning our assumption is wrong, and we said that they are real numbers. So if that part is wrong, then they aren't real numbers. So they aren't real numbers. So that's it for this question. Let's try another question. Okay, let's try another question. Let's try this question out. So square root of 2 minus 1. Let's prove that this one is irrational. So the same way, first we assume, so we say let's assume let's assume that square root of 2 minus 1 is rational and is equal to r. So if we say it is equal to r, so we say over 2 minus 1 is equal to r. So we take the -1 to the other side, making r plus +1, and in this constant we say that okay, addition is closed. This implies that r plus 1 is rational. This is rational. This side is rational. But we know that this side is not rational. So hence they cannot be equal. So if this side is not rational and this side is rational, hence these two cannot be equal. Hence this is a contradiction, and this is irrational. So irrational. Which makes sense because a rational number cannot be equal to an irrational number. So let's try out. Now let's try these other examples. Okay, if you want you can pause the video and try them out. Okay. Okay, let's start with this one. So let's just draw a line there. Okay. So we say suppose or assume if you want. Let's use assume. I like it. Assume. Okay. Assume square root of 2 plus square root of 3 is rational. As usual, we have to assume it's rational. Then we do it in a way that we try to find it if it's rational. Then if it's not, then we just simply say it's not. So okay, let's assume that square root of 2 plus square root of 3 is rational. It's rational. So such that 2 over 3, I mean square root of 2 plus square root of 3 is equal to a over b. So let's try to get rid of the square root. Let's square this side, and this square this side. So what we're going to get is okay, square root of 2 times square root of 2, that's going to be 2. Square root of 2 times square root of 3, which is going to be plus square root. Okay, then square root of 3 times square root of 2, again we're gonna get this 2, simply expanding this. Okay, and square root of 3 times square root of 3, the square root cancel out and we just use 3 is equal to 2 squared over b squared So we can simplify this to, so 2 plus 3 is going to be 5, and we can also simplify this, which will make it plus 2 square root 2 square root 3. Okay, which is equal to a squared over b squared. Now we can simplify this to get 5 plus 5 plus 2 square root 6. To make our work easier, I can do that over. Now the main trick about irrational numbers, about proving irrational numbers, is that for situations like this is that we have to have rational numbers on one side and irrational numbers on the other side, so that automatically you can't a rational number cannot be equal to an irrational number, so that we can say, okay, this is a contradiction, and that is the main trick about irrational numbers. So in this case we can send the 5 the other side, so we can have all the rational numbers one side and the irrational numbers the other side. 6 is equal to over 6 squared minus 5. Okay, let me get rid of this part. Okay, minus 5. And also we can divide this side by 2, get rid of the 2 also by 2. So we're going to have 6 square root of 6 is equal to squared over b squared minus 5 divided by 2. So this we can simplify it. Okay, so this can be simplified, but yeah, so a squared minus 5 over b squared. So this becomes times 1 over 2 is 1 over 2, and which would simply be a squared minus 5 over b squared, or 2b squared. And so we can see that 6 square root of 6 is not rational, and this side is rational. So hence they are not equal to, and well, this statement, therefore this entire statement is not rational. That's it for this question. So we can do the same thing for this one. So this one we can also assume that it is so this is the same thing. Okay, so this is what we found, and so for this one we can see that it has no square roots, and so this one is automatically rational because, well, so that's it for this video. So generally, mostly irrational numbers have square roots. Mostly they're mostly square roots of odd numbers and prime numbers, like these 2 3 2 3 6, these that you can't simply simplify. So that's it for this video. See you in the next